Yum, 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 yum. Here is how you name ionic compounds or salts that include transition metals. Okay, transition metals are all these dudes down here. And I cut off the periodic table. Oops. Okay, so what did you notice about those? Well, yes, they're all metals, so they tend to gain what kind of a charge? Positive charge. Yeah, totally. But what you also notice is that they weren't really in our 1, 2, 3, 4, 3, 2, 1 song. How come? Because transition metals can accommodate more than one type of charge. So meaning, in a given compound, say iron may gain a charge of +2, but it can also, in a different compound, gain a charge of +3. Okay, so here's the thing. Whenever you're using transition metals in the name of a compound, you need to specify what the charge is. The way that we do that is with what's called a stock number. Okay, so here's the deal of what that means. That stock number, this denotes the charge of the transition metal. Okay, so for example here, we got iron oxide. Is that an ionic compound? Yeah. How come? Metal and non-metal. Positively charged thing. What is that positively charged thing on iron? It's +3. How did you know that, Mr. Gorin? It's a transition metal. Oh, because it says in the name, that's what the charge is on that ion. Okay, now, what about oxygen? Well, oxygen just has its regular old -2 charge in an ionic compound. So, what would the formula be of this? How many oxygen atoms would you need to balance out how many iron atoms so that this too were a neutral compound? You would need this, I believe. By the way, this is the chemical formula for rust. Gross. Alright, so again, they're still neutral, but the only thing that's different here in naming transition metal compounds is that you can't use the 1, 2, 3, 4, 3, 2, 1 song. You got to use the stock numbers for the charge. So for example, copper 2 sulfide. Copper, what's the charge on it? +2. How did you know that? Stock number. -2 charge on sulfide. So what's the formula here? That is copper 2 sulfide because they're already balanced, those charges. Okay? So there are two, what is the word? Exceptions. Okay? That is silver. It always has a charge of +1 when in an ionic compound. Zinc always has a charge of +2 in an ionic compound. So you do not need to use stock numbers there. In fact, you will not see them, and you shouldn't use them because it's sort of understood that if it's in an ionic compound, those guys always have that charge. You should make a note of that and sort of be aware of those guys. All right, so now let's just look and make sure, and sorry, the subscript should be sent here, but let's look at this guy. Okay, now we're trying to generate the formula or the name from the formula. Well, is this an ionic compound? Yeah, because it's lead. Oh, and lead's somewhere down here, but it actually is a transition metal. Okay, so that's another thing that you may want to jot down. Chemistry is full of lots of exceptions. Love them. All right, so we got lead. Okay, so we know that we have lead and sulfide, okay, because we got metal and non-metal, so it's going to go under those names. But what must we write if lead is a transition metal? We got to write the charge of it. Can I just write 1 because there's only one of them? No, that's not the charge. What is the charge on it? Well, we kind of have to work backwards a little bit. Okay? If there are 2 sulfide ions, what is the charge on each of the sulfide ions? -2. So that means that these 2 sulfide ions contribute a charge of -4 to this thing. So if this thing is neutral, what charge must this one lead ion have? It must have a charge of +4 for this thing to be neutral. So the name of that compound is lead 4 sulfide. Again, please note that the stock number does not tell you how many of the atoms, it just tells you the charge on the transition metal ion. Alright, have a lovely night or day on the internet.